Well, everybody, thank you for joining the OpenE webinar. Today is December 18th, 2012, and my name is Todd Maxwell. We had this as the last webinar for the year, so we wanted to close it out with some interesting information that we see on the support that we receive on emails and the questions and pre-sales questions as well. So we decided to talk a little bit more about when to use a bond and when to use multipath input-output, known as MPIO. In our discussions, we're going to basically go over the uses for the bond modes and MPIO. We're going to verify the types of NICs and be able to let you know that you really want to be able to keep those NICs in the same chipset. You really don't want to be using, let's say, a 1 gig to a 10 gig with a bond. That wouldn't make sense, and nor would you do it for MPIO. You also wouldn't want to have different vendors as well, or manufacturers. That sometimes can cause problems. So if you have an Intel NIC and you use a Broadcom NIC, not a good idea. We highly recommend to use the same chipsets. We've seen some better effects of it and also some worse effects when you don't use the same chipsets. So verifying the type of NICs is very important when using a bond. And then of course setting the NICs for the bond and which type of bond mode is most widely used that we see. And then we're going to go into MPIO settings. I'm going to show you where you can learn how to set up MPIO with Microsoft Windows 2008. And then for VMware, I'll just quickly show you how easy it is for the MPIO to set up. And of course, a little bit of information about jumbo frames that we've seen cases on that might help everybody here, where if you're setting a bond, but you set the jumbo frames for the bond, but you forget about setting it for the NICs that are assigned to the bond. So I'll briefly go into that and demonstrate that. So on this topic, I wanted to cover some questions and just kind of go over a diagram. You know, NIC bonding. We get this question, when do I need a bond? Well, bonding works best with NAS, first of all, where there's multiple workstations connected. So what you have here is, a different bond that could be set for many NICs. Here, if you look at the DSS down on the bottom there, that could be V6 or V7. And you have a bond, and let's say you have many types of workstations. Obviously, one network interface is not going to be sufficient enough. You can have the fastest RAID controller and the drives, but a 1 gig can only provide so much. Let's say you had 50 users of Microsoft, XenServe, VMware, and Linux, and other OSs. You're going to need more to be able to provide you're still going to be a single path, but you need to provide more of the what's called widening the pipes, so to speak. So when I add additional NICs, then I'm allowing a larger, wider flow of more input-output requests. Now, you can use iSCSI for bonds, also bonds that provide path failover for the selected NICs. So keep in mind that it's not just necessarily with NAS, it is also with iSCSI that you can use certain bond modes. Keep in mind, fiber channel is not part of bonding. It's not part of what we call NIC teaming. So fiber channel is really mostly used with MPIO. So the question is, how many NICs can I have in a bond? Well, you can have as many as the system can handle. But if you are bonding more than 6, even 8, at that point you might want to look to consider a 10 gig. So I probably forgot to say 6 or more 1 gig NICs. Pretty soon you're not only consuming more ports in your motherboard, but if you think about it, it's just as cheap to go with 1 10 gig. And of course, the dual ports are very inexpensive now from Intel. I've seen some of them out there on the internet for $300, under $400 that you can purchase for copper or fiber optic cables, connections that they can use. But really, when you get past 6 or more, you probably want to look at the 10 gig NICs. And of course, I know the switches are very expensive on 10 gig. I've seen some 4 ports, so 24 port switch, and then 4 of those would be 10 gig at a reasonable price under, I think the last time I searched was for LG Ericsson, which makes a decent switch. It was around, I think it would be paid $2,400 for it. Now, next question. Is bonding faster with more NICs? Well, not really. Again, you're still going to be transferring only at 1 gig. But think of it as this. Think of it as if you have all these workstations. Let's say they're people, and you have a 12-foot by 12-foot room. And in that 12-foot by 12-foot room, let's say you have 70 people there. That's a lot of people, and you have a 3-foot door. That would only mean a few people can basically go out that one path. Okay, now we're going to widen the path, and we'll add another door. And then, of course, now we have a 6-foot door, or two 1 gig NICs that are in a bond mode. Well, now we've created a larger single path of flow for the data to be requested and received and transmitted from all these workstations. So obviously it would make sense that you would want to bond when you have that many users connected to the same storage unit. Again, if you're saturating to the point where, let's say you have one NIC, obviously your best you're going to get is about 100 megs, depending upon the file protocol. But if you have that many workstations, obviously 1 gig is going to be your bottleneck, not the RAID array, especially if you benchmark your RAID array to be, let's say, 300 or 400 megabytes. So you really want to look at adding additional NICs to widen that pipe. All right. The types of bonds that we mostly see. Now there are other bonds other than these, but these are the mostly widely used and popular bonds that we recommend and see for their certain uses. So I wanted to go over everybody with them. One of the main ones we do see is a balance RR round robin. Now that could be used with or without a switch, and it can also be used for volume replication and also for NAS volumes. So you can directly connect two DSS systems for volume replication without utilizing one of your switch ports by using balance RR. This is the only one we recommend, especially for volume replication. We've seen some scenarios where older versions of the DSSV6, they were using even 802.3ad and it had some issues, and then ask them why it really doesn't work. Well, it's because you need a managed switch, so especially for balance ALB, adaptive load balancing. But anyway, balance RR is probably the most widely used. So it does the transmissions. They are received and sent out sequentially on each bond slave interface. And by the way, you can look at your information about your bond, is that there is a NIC info in the logs. But we'll just go on because that's a little bit more in depth, and we're going to be doing another webinar on how to read logs next year. So the next one is widely used as the balance adaptive load balancing. Now this is used a lot with our iSCSI with the storage access NICs that where you place the virtual IP on. And the virtual IP address for our active passive and active active cluster feature that we have with DSS. And this is providing the zero point of failure that we're talking about. And I got another slide that we're going to go show in a diagram how to use it. But balance ALB is widely used with iSCSI with our 0 point of failure set up with MPIO. And also can be used with NAS volumes as well. So here you're sending and receiving frames and they're load balanced using the change MAC address tricking that it does. Because some switches will say you got multiple MAC addresses come from one NIC. Obviously you have a problem. So the balance ALB does some MAC address tricking, is what we call. The next widely used is 802.3ad. You need a switch for this that supports link aggregation control protocol, known as LACP. And is used a lot for iSCSI and NAS. What's valuable here is that it creates aggregation of groups that share the same speed and duplex settings. It has some algorithms to understand the single flow that it has from multiple requests coming from, let's say, different hosts. And it provides path failover as well as performance. So what it's doing is utilizing all the slaves in the active aggregator. So again, you need a real switch that has 802.3ad that also supports dynamic link aggregation. We see a lot for iSCSI on this, just on a single path, but for the real effective use, MPIO would be better than 802.3ad. So mostly we do see it a little bit on iSCSI, but a lot more on NAS. The balance transmit load balancing, the TLB that we have, recommend with a switch. We don't recommend to directly connect to, let's say, another DSS for the volume replication. Again, we recommend the balance RR for the volume replication. So this also supports for iSCSI and NAS, but what's different about this than the ALB, which is the adaptive load balancing, is that this is for transmitting out. So what the channel bonding is doing, even though it doesn't need a special switch, but you do need a switch for it to do the outgoing traffic is distributed according to the current load. So it does like a computative related to speed concept. So on each slave is the way it's working the loads out. So incoming traffic, though, is received by the current slave. And if the receiving slave fails, well, obviously another slave takes over and the MAC address of the failed receiving slave. So those are the most commonly used are the balancer R, balance LB, ALB, and of course 802.3 AD. Now, let's talk about multipathing. When do I use multipath? The most usages are going to be with iSCSI, but some can be used with Fiber Channel. So there's some webinars that have been done with using Fiber Channel and MPIO with VMware, Xen, and Microsoft. But mainly we're seeing a lot of MPIO with the usage of iSCSI. It does not work with NAS, so bear that in mind. But it requires a minimum of 2 NICs. So this allows the MPIO server with multiple NICs to transmit and receive the input-output data across all available interfaces to a corresponding MPIO enabled server, such as Xen, VMware, Linux, and Microsoft. So if you look, any one of the servers on the left side, the Microsoft, Xen, and VMware Linux, you have 2 NICs. You can have more, so you can have more paths. So remember, bonding has a single flow, okay? Where multipath, I'm using all available paths on those NICs. So here where you increase the speed and you have path failover. But you can add, let's say if you take the DSS, V6 and V7, the server down there, you can add another 2 NICs and have 4 multipaths working for you. Of course, you can segregate where 2 of the NICs for multipathing could be for the Linux and VMware, and the other 2 NICs could be for the Microsoft or Xen, or if you eliminate all of them for VMware and had VMware just with 4 NICs, then you would have 4 multipaths working for you. And of course, on the DSS side, you would need 4 NICs. So again, as I stated, does multipath provide failover? Absolutely. If one of the NICs fail, all the data and path will be directed towards the other NIC assigned to the multipathing configuration you have on the host. So the host is smart enough to be able to utilize its CPUs and its algorithms to be able to do the switching. And so this is where multipath is also valuable. Here it states is that, do I need a switch with MPIO? No, you can actually go directly to the server. I've done this personally where I'm utilizing 2 10 gig NICs on VMware and 2 10 gig NICs on the DSS side. And on each of the NICs I have separate network addresses for each of those NICs. And of course on the VMware side, I would, in my initiator settings, to connect to my storage, I would set in the IP addresses for each of those NICs, and I'll show you that. It's pretty simple to do, but you just basically can use direct connection, and of course you can use a switch. So this is a valuable thing to know about when and how to use bonding and MPIO. Now here's the last slide. So in the case where can I use bonding and MPIO at the same time and all in a configuration? And keep in mind, there's a lot of ways you can use the DSS in many different ways of having multiple bonds servicing for NAS. You can have bonds with MPIO. You can have MPIO just directly for certain functionalities that you don't want it on a switch, you don't want to share it, and you want to directly connect to, let's say, a initiator that is going to be used for database or email exchange. So you can have different various configurations. So I try to get a best scenario here of the all-encompassing way. If we look on the right, I have volume replication with a bond. Remember we talked about that the balancer R round robin only can be used with volume replication, and you can do it without a switch. Of course, you can have a switch in between, which actually you're adding additional fault tolerance. So you would be able to bond the switches as one logical switch with a trunking protocol. that if one switch fails, you don't have a path that fails with you and take the whole system down. Obviously, if you had only one switch and both of the NICs are connected, or both of the DSSs are connected to that switch, and that switch fails, well, obviously you have a single point of failure. The best option would be if you have two switches between the volume replication, and then use balance RR, and each NIC would go to each switch. So that would provide you a zero-time down failure that is appropriate. But you could, if you want to eliminate a switch and a switch port count, you could directly connect to two DSSs for volume replication. Now on the left, you're going to see balance, adaptive load balancing. Here is where we recommend to use, especially with the active-passive, the active-active. So you would take two NICs, select your bond of balance ALB, and each of them would have their own IP address. And on top of that, you see with the red circles where I pointed out where the balance ALB is for those four NICs. So I have two that are in a bond, and for the MPIO, and I would specify for, let's say, a virtual IP address for my clustering with active-passive or active-active. And of course, I would set those virtual IP addresses for each of those bonded NICs. So here, if you look on the left, the initiator again could be, let's say, a VMware, a Microsoft, a Linux, a Zen server, and we're going to be utilizing MPIO with the iSCSI initiator. So now we have four paths to be able to work with for load balancing, for performance, and also we could utilize this for active-passive or active-active. So we have some diagrams for that. Let's go right into the DSS and show you where we need to go ahead and set the bond mode. So let's just take a real simple example for some of you who are not familiar with setting the bonds. If we just take, let's say, I have a bunch of NICs here. These are 1 GeS from the Intel NICs, and I've got this one NIC, which is, let's look at the third octet, which is 8.220. So it's going to be ETH8 and ETH9 that I want to be able to make a bond mode out of. So here, let's just envision I'm going to be utilizing this for my active-passive. So I'm going to set this bond mode. I'd like to make them for adaptive load balancing. To do this, I would just go to Interfaces, and I clicked right up here, and I scroll on down. And here's my default gateway information. If I keep scrolling down, I have my static route managing functionality. And here is where I can create new bond interfaces. Now, if you basically want to go back into the information of what each bond does, you can click on this question mark, and it brings up this window, provides you information about each of these bond modes, and here you can see basically the same topics that I've just covered with you. So what we're going to do is we're going to select ETH8 and ETH9 for our bond. So here, if we go into selecting ETH8 and 9, we will see that we are going to select our bond. We'll use ALB. We'll set our IP address. And I don't need a gateway, considering this is just going to be for inside my storage area network. And then what you'll see on the left side is there's going to be a new bond interface, and that'll be noted as bond 0. I can bond as many as I want, as I stated before. Up to a certain point, it just doesn't make any sense to go beyond 6 to 7 NICs to bond, because at that point you might as well purchase a 10 GeS. So here it's updating itself, and on the left side you'll see that it's created a bond 0. So right here on the left side you see, and it's also noting ETH8 and Ethernet 9. It's denoted as a bond 0, and here we see bond 0 and the information. Now what I wanted to mention to you is that what we want to do is, I wanted to point this out to you. I wanted to show you that if you're going to use jumble frames, you're not going to be able to do it in the GUI here. Where we set the jumble frames is in our hardware tools in the console screen, because it's a deeper function. But what I want to show you is that if you're going to use jumble frames, bear in mind that you should do that before you create the bond. I'm going to show you why. So here we're in the console screen. We're going to go to Control-Alt-W. So this is where our hardware tools are. Of course, I even can type wrong. Password. Now we're going to go right into tuning options and jumbo frames config. Now what we're going to be getting is a list of all the NICs. You noticed ETH 8 and 9 are no longer available, but Bond 0 is. So here is where I'm going to be setting my jumbo frames, because the default is 1500. Ideally what you should do, we're going to go back. What you should do is set the jumbo frames before you create the bond. So what we should do is go back to the DSS and let's remove the bond. And by the way, I want to let you know that if you do an 802.3 AD and the NIC's already connected to the switch, make sure that you configure the switch for those ports for the link aggregation control protocol. So you want to set that up before you actually set your 802.3 AD bond mode before you do your NIC, your switch. So do your switch first. So as this is removing the bond, basically lets you know there's no bond slave interfaces. Now we can go back, and here let's just go switch back to refresh the screens, go to jumbo frames, and we should see ETH 8 and ETH 9 available. So what we want to do now is we'll go set this, set it for a jumbo frame of 9000, hit apply, and then we're going to set this for ETH 9 as well. $9,000, apply. Now we'll go back to DSS, and now we can properly create our bond mode. So let's scroll down, select ETH 8 and 9. Again, I can select more than 2. I can go up as many as I want. So here we'll just do it for right now. We'll just select the adaptive load balance, specify our IP, and we'll take the default net mask and create our bond. So now, while this is updating, on the left side we'll see bond 0. Obviously ETH 8 and ETH 9 are inoperative. So inoperative because you're creating a bond, so those are joined. So whatever IP address you had originally on there, you will not be able to utilize them. So bear that in mind if you have users. Before you create a bond, make sure that the users are connected to another NIC interface, so that way they're not being able to have their connectivity to their data. So now we have our bond 0 created, and we can go back into our console screen. Let's do an update for the refreshing. And here we see our bond 0. Now we can set our bond to be 9000. Too many times we see in tickets that come in that we see cases where they only set the bond 0, but they didn't set the underlying NICs. Okay, now let's look at MPIO. Here I have on the VMware server that I have here. First I want to show you that my storage adapters, if we go down here to the iSCSI software adapter in a VMware, and I go to my properties, I've already configured it because it saves time. As you all know, you're doing discoveries, you could sit there and wait for a few seconds or more, and we're just shortening up the process. These are my 2 NICs from my DSS server. So let me show you. If I bring up DSS V7 and I go to ETH2, you'll see that I have 10.10, 3rd and 4th octet for ETH2, and on ETH3 it'll be 11.11. Okay, now if we go back to the VMware server, here you'll see I have the iSCSI server location, which is the IP address, and of course the protocol port number, and I set that in there. So I have both those NICs, and it's going to see it as 1. And here you'll see it as 1 target being brought in instead of 2. Now it's intelligent enough to know this. So now how do we make multipath work for VMware? Well, it's real simple. If you go right up here into storage, obviously we brought the storage in, and you click on your storage right here, and you see your VMFSS type here. You go to properties, And in properties, you'll see right down here, manage paths. Now by default, this is what's going to happen right here. It's going to be one is active I/O. What you need to have is both stating active I/O. So what we'll select is we're going to be selecting this guy also to be a round robin VMware. And now when you see both of them stating active I/O, then you have multipath working. So anytime if one of my NICs on the 10.10 or the 11.11 NICs that I have were to fail, accidentally be pulled or whatnot, then data can still be transmitted over to the DSS, and also vice versa, input outputs. For the Microsoft, what I wanted to bring everybody's attention and kind of guide you back into where most of our information is located. Here, if you go into support how-to resources, you'll see some documentation right underneath others. And here you could see how to configure DSS v6, also works for v7 with Windows 2008 Server. And if you click on view, not only do we tell you the whole process, we go in through the setup of configuring the volumes, the target names, obviously being able to configure the Windows server, where to get MPIO. These are some of the features that you have to add in the Windows 2008. In 2012, I think there's a different process, but it's similar. Here you discover multiple paths. So there's a lot of information that we walk you through the whole process to guide you to enable, here as you can see, multipathing for iSCSI. So, a lot of good documentation I want to bring your attention to. And of course, if you want to know more about the bonding versus MPIO, we have a blog that bonding versus MPIO explain. So it's a little bit more deeper information that might help you make that choice of which way to go with a bond or which way to go to MPIO, or actually both. Well, I wish you all a happy new year. It's coming up in front of us. Thank you for watching and coming to the OpenE webinars, and please see us again for the next sessions that will happen for 2013. Take care, everyone. Bye-bye.